Alright, if I take a look at 26, 26 said I have 2 comma negative 4 and 0 comma negative 4. Alright, and it's telling us to write an equation of a line that passes through the points. Alright, well first of all, we already have our y-intercept. So I just need to find my slope. So my slope is y2 minus y1 over x2 minus x1. Alright, so I'm going to do, this is going to be my x2, y2, this is going to be my x1, y1. So I have negative 4 minus a negative 4 divided by 2 minus 0. If I do A in the opposite, I end up with 0 over 2. Alright, well there's my slope. My slope equals 0. Alright, so if I put this in, y equals mx plus b, I get y equals 0x plus a negative 4, so that means y equals negative 4. What kind of line is that? When I have a 0 in my numerator, what kind of line is that? We did this back in the beginning of chapter 3, right? Rita? That's a horizontal line. And if you remember, horizontal lines, or do we talk about this? Horizontal lines are y equals. Did we talk about that at all? Have we talked about that? I don't think we have we? Okay. So we'll talk more about that as we get closer, as we get into standard form. We'll talk about that, but that's a horizontal line. If you left it like this, that would have been fine with me for now. Does that help you? Awesome. What else can I do? Giselle? All right, let's take a look at 10. All right, so number 10 said, I'm not going to redraw that, but they did, it says write an equation of the line shown here. All right, well, our slope, they've already kind of done our slope work for us, so they've kind of made it easy on us. Their slope is, it's rise over run. So we're going up 3 and to the right 3. So my slope is 1. And then if I look, they gave us the point 0 comma negative 4. Well, that's our y-intercept. So I have y equals mx plus b. So y equals 1x plus a negative 4, or y equals x minus 4. Those are the same thing. Does that help you? Awesome. What else can I do for you guys? You guys good? Okay. So put this away, get your notes out. I first want to start with beating up tables. All right, we're going to be using these as we move forward. All right, so we are continuing on with 4.1. So 4.1 continued. And we are writing linear equations in slope-intercept form. All right, so there are 3 ways we can represent a linear function. The first way is from an equation. Second way is from a graph. And the third way is from a table. All right, so we're going to focus right now on how we determine if a table is a linear table. So determine if a table of values is a linear relationship. Alright, so what we're going to do is we are going to beat up tables, which is what BU means. BU means beat up. So we're going to beat up, or BU, tables. Alright, what that means is we're going to find the individual, and I think we've done this before. Have I done this before with you? We did this in the first section, right? Or we did this in the previous chapter? Okay. So beat up the individual sets of consecutive points. Find the slopes. If all slopes are the same, table is linear. Now, what we haven't done in the past is we haven't written equations from them, or haven't had much. So what we're going to do is we're going to then write an equation for the table. What are the two things I need to be able to identify on my table for me to be able to write an equation from the table? So once I determine that it's linear, what are the two elements I need from the table to be able to write an equation? Joseph? Nope. Remember, we're writing a table in slope-intercept form. Giselle? Yeah, we need our slope, and we need the y-intercept. What does a y-intercept look like when we have coordinate points? Like, how am I going to be able to identify a y-intercept on a table? Hello? More than two people are thinking. How am I going to identify a y-intercept on a table? Elle? Yeah, so whatever it is. So remember, my x value is 0. All right, so let's take a look at a table. I'm going to flip. Let me go up here. So let's do, who needs to see what's up there? All right, so what I want you to do is I want you to beat up the following table to determine if it's linear. If it is linear, I want you to write the equation for it. So beat up the table. To determine if it is linear. If so, write a slope-intercept equation for it. Okay. Hang on. I think that's going to work. All right. Beat that up. Determine if it's linear. If it is, let's write an equation for it. So remember, you are doing a change in y on the right, you're doing a change in x on the left. So you're creating two more columns, or you're doing this work off to the side. Because eventually we need to find our slope, which is change in y over change in x. So I'm going to do this as you're doing it. I'm going to hide mine though. Uh-oh. Hang on. Hang on. We need to adjust something here. You'll be fine. You can keep that one. There. Okay. Adjust that. Uh-oh. This is what happens when you do it without looking. Hang on. Because I want this to work. I know, you guys. I made this off the top of my head and it wasn't working all that well. 6. There. Keep going. I know. I'm adjusting as I go. You'll be fine. This still may not work, but we'll see. Sorry, this is the risk of doing things on the fly. But you guys can adjust. I know you can. So this should have been what you got. So this is the work I should see. I should see your subtraction. Either you do the first minus the second, first minus the second, first minus the second, or you do the second minus the first, as long as you're consistent. All right, and if you simplify, I believe, if I did this right for the third time, we should have a slope of 4/3. How many of you guys got a slope of 4/3? Awesome. Okay. So we know the slope of 4/3, so the table is linear. Okay. Now, we have our slope. What's the other thing I need to be able to write an equation? Rita? Do I have my y-intercept? Which one? What is it? Yep, so there is my y-intercept. So all of you write an equation for this line, or for this table. Don't forget to write your generic formula down, y equals mx plus b. Rita, what's my equation? Excellent. Okay, now the question is, what happens when they don't give you a y-intercept? So I'm going to give you, if you have your worksheet out, you need to put it away. So if any of you guys have your worksheet, put it away. Because I am going to do one that's actually on our worksheet that I already have worked out for you on the worksheet. Okay, so now you're going to have it in two places as kind of your guide. Okay, so let me give you this table, and I want you to start beating it up, and then we're going to figure out how we come up with our y-intercept. This is one way from a table how we can come up with it. Okay, so I want you to do the same thing here. So here is my table. This one does work. My x values are -2. Hang on a second. Is that negative or positive? No, it's a +2. +2, 4, 6, and 8. And then my y's are 9, 14, 19, and 24. So 2, 4, 6, 8, 9, 14, 19, and 24. All right, beat up this table. Determine if it's linear. How many of you guys got a slope of 5 over 2? Awesome. So it is linear. Now, the problem is I don't have a y-intercept on here. So what you're going to do for my y-intercept, go backwards on the table. Okay. What was I adding to each x? Because I need 0. What was I adding to each x to get the next x? What am I adding to each x to get the next x? Seamus? 2. If I go back 2, do I get to my 0? All right. So here, I'm going to subtract 2. So here, going this way, I'm adding 2. So I only had one jump. That jump is just adding 2. Does that make sense to you guys? So to go from the first to the second, I added 2. I added 2. I added 2. And that correlated in my y's with adding 5. So when I added 2 to my x's, I added 5 to my y's. How many of you guys recognize that? Okay. So if I subtract 2 from my x, how am I going to get its corresponding y value? Maya? Subtract 5. So what is 9 minus 5? Mia? Maya? Kina? Because I have too many of you. 4. There's my y-intercept. So you have to kind of pay attention to, if I hadn't given you the 2, 9, and I am adding 2 each time to get from one x to the next, and 5 each time to get from one y to the other, I would have to actually go back 2 groups, subtract 2 twice from my 4, which gets me to my 0, which means I would have subtract 5 twice to get to its partner. Does that make sense to you guys? So you're going backwards on the table. So now somebody write my equation for me. So it's y equals mx plus b. Somebody write my equation. Al? Excellent. You guys cool with that? Okay, so this is going to help you, Carmen, this is going to help you with your worksheet. You do have another one on there that you don't have the y-intercept on your table. So practice that. The one that we just went over is on here for you to consult with when you're doing these worksheets. Okay? You guys cool? Okay. So now the other thing I need to talk about, now that we've done tables, we need to talk about story problems. Okay? I know it's everyone's favorite thing to do, but I try to make it as easy as I can for you guys. All right, so when we're talking about slope-intercept story problems, first of all, if I review something, so I just want to review. When we have direct variation, what phrase in a story problem indicates we have direct variation? What phrase in a story problem indicates that? Lily? Yep. Y varies directly with x. Okay. We have a similar phrase for slope-intercept. All right. So our phrase indicating slope-intercept. Y as a function of x. That's the phrase you're looking for. Y as a function of x. An example of that might be total cost of gym membership as a function of number of months. That's what one might look like. Right? And if we take a look at this, here's my as a function of, which means my information before it must be my y, my information after that must be my x. Y as a function of x. Total cost of a gym membership as a function of the number of months. So that's what you're looking for. that indicates we have slope-intercept. Now, again, to write a slope-intercept equation, we need our slope and we need our y-intercept. So let's talk about what those look like in a story problem. Well, what do you suppose a slope is going to be in our story problem? Keep in mind, a slope is always being multiplied by our x. So what kind of number is always going to be our slope?
Teachers and students, please pardon the interruption. We have Ashley Hamama to do our afternoon prayer.
In the name of the Father, Son, Holy Spirit, Amen. I pray for everyone to be patient and quiet on this Advent day. Let us pray for those people who welcome Christ in this union of the world. Help us show Christ to others during this Advent season. In the name of the Father, Son, Holy Spirit, Amen. Thank you, go.
Great job, Ashley. I'd like to wish a happy birthday today to Graham Clark in the preschool, and to Julie and Georges. Happy birthday, both in our preschool classes. Happy birthday today to both Graham and to Julian. Those are your announcements for this Wednesday. Have a wonderful rest of your Wednesday. Thank you.
All right, so how do you think we see a slope in story problem if it's always the number being multiplied by our x information? Rafaela? That's a rate. It's always a rate. So your slope is always going to be a rate. Your y-intercept is always going to be a one-time cost, a one-time fee, an initial amount, your y-intercept does not depend on your x. It does not depend on your x info. So it's not going to be a rate. All right, so let me show you a story problem, and I want you guys to do this. Remember, look for that phrase, something as a function of something. That indicates you've got slope-intercept, and then you're going to go back in and you're going to find the rate, which is your slope, and you're going to find a one-time cost or a one-time fee. Hopefully they have it in there, and these should. All right, this is example 5 from page 225. I know some of you like to write that down. This is example 5 from page 225. All right, I want you all to do this problem. If you notice in part A, you're writing the slope-intercept equation with variables in it, and then B, you're using it. So example 5 from page 225. Can you guys see that phrase in there? It's important. Write that phrase down. I mean, you can shorten the words up, but write that phrase down. That's going to help you identify your variables. All right, remember, before you write your equation, you don't need a game plan, because we know that this slope is slope-intercept form. So you just need to write down y equals mx plus c. That's really your game plan, is that format. All right, always identify what X stands for, always identify what Y stands for before you write your equation. Just like we did for the rest of the other equations that we've written. So you're writing the equation that gives total cost as a function of the number of hours in the studio. You do not need to make a table of values. You're writing an equation. So you're writing an equation and then you're using the equation. I don't care about any other total cost other than 10 hours. All right, so you're writing an equation and then you're using it for when finding the total cost for 10 hours of studio time. How you doing, friends? You good? All right, well, let's take a look at this. So I like to share with you things that help me because I feel like they're pretty functional and they can help you as well. I always write that phrase down, just like I did the phrase with direct variation, because I know y as a function of x. I can see right away what my x information is and what my y information is right from there. All right. So now, because I know it's y as a function of x, I am going to use slope-intercept form. So that's an automatic indication. Now, all slope-intercept form is not going to say that, but when you see that, you're like, sweet, now I know it's slope-intercept form. All right, so let's go back up and identify the things we have. Do we have a slope? If we do, what is it? Maggie? Yep, there's my slope. All right, do I have a b value? Carmen? Yeah, because that's an initial phi. There's my b because it's an initial phi. So I have everything I need. So somebody write my equation for me. Go ahead, Carmen. Excellent. So there's my equation. So now we want to know the total cost. We want to find total cost for 10 hours. Ashley, what do I do with that? How do I find the total cost for 10 hours? Excellent. All right, so I have 350 plus 5. So what is the total cost for 5 hours, or 10 hours, Ashley? Oh, wait, that should be a 0. What should it be? 400. So 10 hours of studio time would cost $400. How many of you guys got it? Awesome. All right, let me give you another one. All right, I want you to do this. And then I'll tell you what I want you to do with it. So you're doing extra example number 5 here. So go ahead and do that, please. So somebody write my equation for me. So here's my information. Somebody write my equation for me. Rita? So y equals 25x plus 20. How many of you guys agree with that? Okay. So then someone tell me, how many hours can I afford if I have, I'm making this up, if I have $750 to spend? So how many hours can I afford if I have $750 to spend? Remember, when you're done, make sense of your answer. What variable am I putting that $750 in for? Molly? Yeah, you're putting in for the y because that's your money. That's why it's always really important to identify your variables. What'd you guys get for an answer? Rita, what'd you get? Exactly?
No.
What did you get for your answer? 29.2 hours. But what are you saying is your actual answer? Why not round it up? Yeah, I don't have enough money for that for 30 hours. I only have enough money for 29. So what does that mean I'm going to have left? Am I going to have money left? No, if I have 29, if I wrote it as 29 hours, would I have money left? Yeah, there'd probably be some money left, wouldn't I? Because I really can afford more than 29 hours, but can't go over, right? So I would say I can afford 29 hours of instruction. You guys cool with this? Okay, you guys are good to go.